Hello, dear students. Today we will talk about data mining techniques. First of all, we will talk about attributes and objects of data. Then we'll go for types of the data and data quality, similarity and distances, and data pre-processing. So as we know that there are various types of data, but before talking to the related to the types of the data, I would like to explain that data is a sets of facts and figures, right? So it could be anything. It could be like numbers. It could be text. It could be image. It could be video as well. So data sets is basically the collection of data objects which we call as a rows, and it's also contains attributes, which means the columns of our data. So what is the data basically? So as I told you, it's a collection of data objects and attributes. So it means that it's a collection of rows and columns. So an attribute is a property or characteristics of an object. So as I told you, like for example, attributes could be like column name, like eye color of a person, temperature, etc. Uh, Attribute is also known as like some books they write as a variable like field, characteristics, dimension, feature, column. So there are different names for it. Now we come for like object. So object is basically the record. It could be a certain point could be showing about the data about the customer, case, samples, entity, or instance. So attribute values, like there could be different values in the attributes. So as we already know that the difference between uh, the attributes and objects. So there could be like distinction between attributes and attributes values. So attribute is the name of the column, and values is inside the values we have it. Like for example, height can be measured in feet or in meters. Different types can be mapped to the same set of values. For example, attributes values for ID or age are integers. But properties of an attributes can be different than the properties of the values used to present the attribute. So if you see over here for the measurement of the length, right? So on the one side, we can see that there is an ordering, but there is no additive property. On another side, if you look, so there is an ordering plus additive property as well. So the types of attributes we have are like, as I told you that it could be nominal, means like, where there is no order, like for example, eye color, zip code, etc. Ordinal means when there is an order is there, like for example, taste of the potato chips on a scale of 1 to 10, grades of the students, like height, either it could be tall, medium, or short. Intervals are like when these are the basically numbers, but where zero is not the real zero. It means that, for example, calendar dates, so there is like interval over there with a shift of 1 day. There could be like temperatures. So in temperatures in Celsius and Fahrenheit, the zero is not a real zero. So if we say that there is a 0 degree centigrade, so it doesn't mean there is no temperature. It means there is a temperature, right? So it also goes to -1, -2. So depending on the temperature of a certain place. And then we say like ratio. So ratio is like where there is a zero means zero. So zero length means no length. 0 Kelvin means no temperature. And then elapsed time is like time to run or race. So like properties of different attributes could be like distinctness, like means it could be equal or not equal, order less than or equal to. Differences are like meaningful, like it could be plus minus, or ratios you can have like you can divide and multiply as well. So if you see your here nominal attributes, they could be differentiated through distinctness, like where there is like equal or not equal. For example, red color is not equal to blue color, or red color is equal to red color, right? Ordinal attributes is like distinctness or an order, like there is an order, for example, grade A, grade B, grade C. So grade A students equal to another grade A students, and there is an order as well. Interval attribute is like, for example, it has like distinctness properties, it has order properties, and they have like meaningful differences with the plus and minus. While the ratio attributes, they have like all the four properties operations over there. They can be like distinctness, order, differences, and ratio as well. There are certain examples between the ratio and the interval, as we already discussed that like Celsius and Fahrenheit they are considered as an interval, while Kelvin is considered as a ratio. There are certain some more attributes related to about the attributes type, and its descriptions is given over there along with certain examples. If you see for the nominal, we have normal attributes, example like zip codes, and operation could be like mode, entropy, contingency, correlation, and similarly there are examples for ordinal, internal, and ratios. And how we can transformation with respect to comments like nominal, any permutations could work. Permutation means the change of order. If all employees id numbers were reassigned, would it make any difference? So like yes, of course, the id for every employee is specific, right? So if you change the order, so the record will be changed. And similarly, if you see the for like ordinal, an order preserving change of the value, so order is important over here. Like for example, in nominal the order is like not important, but in ordinal the order is important. Interval, like interval is, as I told you, that Fahrenheit and Celsius, and ratio is any numbers like length, and Kelvin is also a ratio. Discrete and continuous attributes, like discretes are like the one which is not dividable, or which is not like they don't have a points. Okay, like for example 3.5, 3.6, these are not discrete. So if you say 1, 2, 3 where there is a jumps, that's called discrete. Continuous are like salaries when there is a points over there. It could be temperature, like temperature is also like it is like 13.5, 13.6. Height is also in points, and width is also in points. While zip codes could not be in points, counts cannot be in points, like set of words in collection of documents. So these are like not discrete. These are like a diagram where you can see qualitative and quantitative. So quantitative we divide into the discrete and continuous. So discrete is without points, and continuous is with points. While in qualitative we divide into the three different one: nominal, ordinal, and binary, right? So nominal is with there is no order, ordinal there is an order, and binary we have like symmetric and asymmetric. Critiques of attribute characterization. So there is different attributes like asymmetry, binary, acyclic, multivariant, partially order, partially membership, relationship between the data. And then we have like real data is approximate and noisy. So if you have real data, definitely there would be some noise, some errors, or some missing values. This can complicate recognition of proper attributes type. Treating one attribute type as another may be approximately correct. So key message for attribute types, like the type of operation you choose should be meaningful for the types of the data you have it. Like it should be distinctness, order, meaningful interval, and meaningful ratios are only four among many possible properties of the data. The data you see often numbers or strings may not capture all the properties, may suggest properties that are not present. And analysis may depend on other properties type, like many statistical analysis depending on the distribution. In the end, what is meaningful can be specific to the domain. So these are like some extra information related to the data. So here you see the types of the data with respect to shapes, with respect to data type, and with respect to the structure. So if you look at the structure, so structure, we have like structured data, and just like we have a tables in a databases or Excel sheet, that is called structured data. Then we have a semi-structured data, and just like we have a logs, we have like a XML file, JSON file. So these are like semi-structured data within a text file or notepad file. Unstructured data, some people they call it binary data, or unstructured data means like data which is not in a proper format. It could not be read by the SQL structured query language tool, right? So that is unstructured. It means it could contain like PDF files. It could contain like a Word file. It could contain like different like videos, audio. So that's called unstructured one. And in data types, quantitative, as we already discussed about the continuous, discrete, ordinal, and nominal. So no need to discuss it further. And then we have like a shape like wide and long shape. These are the example for structured data. You see the tables, and for unstructured data we have like textual data, image data, video and audio, and then you can see uh, the semi-structured data or semi-structured data, that is called XML, JSON, and sensor data. So sensor data is also referred as a, because it could be read by the SQL. So important characteristics of the data are like we have like is a dimensionality, the number of attributes we have it, and yeah, so the important characteristics of the data are like dimensionality means like how many columns it has, how many attributes it has. So more number of attributes, uh, uh, so it means that the prediction would not be that much accurate. So we need some selection of the attributes or the columns, and there are challenges over there. So we have some techniques like filtering techniques or wrapping techniques, or we have majority voting or mutual congestions, or like the embedded schemes. So there are a lot of techniques to pick the most effective one. Then we have a sparsity, or like sparsity means like only presence on the counts. Resolution like mean patterns depending on the scale. If your data is depending on the scale, predefined scale by anyone. And size means types of analysis may depend on the size of the data. And then we have types of data sets like record. It could be like data matrix, count data, transaction data, a graph like World Wide Web or molecular structure. And then we have ordered one like spatial data, temporal data, sequential data, and genetic sequence data. So this is simple record where you can see over here that how attributes and objects are fixed in a shape of a table. Then if you have a data matrix, here you can see the data is in the shape of the rows and columns. Then we have document data, that in the document data, that how many times if for example team is repeated or coach is repeated or play is repeated over there. So because since the Google is also working on the index, like they have specific indexing for a special kind of document, so you don't need to search all the documents. So they just like they index the document. Each term is component attribute of the vector. The value of each component is the number of times the corresponding term occurs in the document, right? So here you can see that how many times one word is repeating in a certain document, right? So let's suppose in document number 3, like game is repeated 2 times, win is repeated 2 times, lost is repeated 0 time, and timeout repeated 3 times. Transaction data is a normal like transaction data in different marts or in a different like shops, like we have Walmart or any mart we have it. So you can see over here that how the transaction data looks like with respect to the transaction ID and the items someone bought it. Graphic data is, it could be representation for molecular structure, it could be representation for like genetic graph, or it could be like about the web pages when the web pages are linked to each other via hyperlink. Order data is means like it depends, the first elements of the order pair is like item, or the second could be the event. This is the data about the genome sequence data, and usually this there is the order is important over here, because to differentiate between one person genes with another person genes. So in this case, what happens, and technically this is called pasta, like in a genetic language, and there is some threshold values, like sometimes you can keep threshold values for 80% or 90% related to the accuracy factor. This is spatio-temporal data. Here in this one, you can see about the data related to the geography and the temperature of a certain place, related to the land and oceans, and how it varies with respect to the different months of the year. Data quality, like poor data quality, negatively affects many data processing efforts. Like, data mining example, like classification model for